How's it going, everyone, and welcome to today's Wikipedia article, which is about a phenomenon known as redshift. I actually know a bit about this because I'm a bit of a physics boy. So if you have an ambulance that passed by you, it makes noises like wee woo, but if you pay close attention, you might notice that it sounds different when it's approaching you versus when it's going away from you. As it gets closer, it gets quicker and higher pitched, but when it goes away from you, it seems to slow and get lower pitch. What's going on is known as the Doppler effect. So sound is a wave, and like any wave, it needs to pass through a medium. In this case, it's air. If a source of sound is stationary, the sound waves it produces will be circular, starting from the source and working its way outwards. But if that source moves, you can see how the wave starts to bunch up in the direction of travel and kind of lag behind in the opposite direction. So when sound bunches up, that's the same as its frequency going up, and when the ambulance gets closer, its sound waves get all bunched up, which is why it sounds higher pitched. But when it goes away from you, all those sound waves get stretched apart, which is why it sounds lower pitched. Now, as it turns out, the same phenomenon happens with light. Since light is a wave, it too has to follow this Doppler effect. The difference is that light waves that are bunched up go up the electromagnetic spectrum, and vice versa. What you're seeing on screen is the scale of the spectrum from radio waves, microwaves, infrared visible light, ultraviolet X-rays, and gamma rays. If we zoom in on the visible light part of the spectrum, we see that red light has the longest wavelengths, while violet light has the shortest wavelengths. Tying it all together, if there's a light source that moves away from you, those light waves will get redshifted, meaning that when you see it, they are more red than normal because the light waves are spread apart. The difference between light and sound, however, is that light moves way faster than sound. So to make a noticeable difference, that light source has to be moving a lot faster, like hundreds of miles per second faster. There's not that many things around us that move that fast, except when we look up. The galaxies that we see in the sky are moving away from us since the universe is expanding. So what we actually see is light that looks more red than it should be. But yeah, that's pretty much it. Here's the feature comment from last video.